So an alcohol functional group is considered a weak acid, right? So it can act like a proton donor, but generally requires a strong base to do so. But that makes a big difference in its chemistry because it can act like an acid. It can act like a base as well. It actually reacts somewhat similarly to water in that case, right? So two alcohols, two smaller alcohols here. Which one is the stronger acid? The stronger acid is the vinyl alcohol, so the alcohol here that has a double bond on there, right? So see, there's a pi bond, it's affecting its acidity. You know, we're looking at how resonance affects acidity in this case, right? So like any acid, the key to really understanding how that works is looking at the conjugate base, right? So we can explain the stability and acid strength for organic structures based on conjugate bases. Right, so remember the conjugate base is just, what is the structure after it's given up that proton? So if we minus H plus, remove that hydrogen, you're going to have oxygen with a negative charge. Same here, right? Oxygen with a negative charge. And then the things that can affect based on these organic structures, we have all of these other atoms covalently bonded to them, right? Those can affect the acidity or the base strength or the nucleophile strength, and it can affect that charge nearby, right? So the acid strength really depends on the conjugate base strength, and if we're comparing these two structures, right, they both have the same oxygen atom with the charge, right? So they have the same electronegativity because they're both oxygen of the atom holding that charge, and they're of the same size. Right? Electronegativity and size are two things that can affect conjugate base stability and affect acid strength. The big difference, of course, is there's some pi electrons here. Right? So why does that make a difference? Right? So this molecule can do resonance. And share its electrons that way, right? So resonance is a trick to drawing electron sharing, and electron sharing is a really big deal in organic chemistry. It can tell us a lot about our stability, our reactivity, and things like that. So let's make some space. Right, so our first atom here, that oxygen's lone pair of electrons, its negative charge has nowhere to go. Right? You can't share with this sp3 carbon. There's no lone pairs there, no pi bonds, no places to do resonance there. It's kind of stuck on that atom. Right? Our oxygen next to a pi electron source, well, those electrons can share. Right, so if these move down, this moves down, we get a second resonance structure. That would look like this. Right? So our negative charge is now on the carbon, which means that overall, those electrons are spread across all three atoms between oxygen, carbon, and that charge is shared between the oxygen and the carbon on the end, right? So this is resonance electron sharing. What we're really doing is spreading out that charge, right? So whereas on this example, the conjugate base of the simple alcohol, or ethanol here, all of those electrons, all that electron density is tied up just on that oxygen atom, whereas here, it's really spread throughout the three, making it overall more spread out charge, right? So if the charge is more spread out, what we're saying really is this is a more stable molecule, right? It's a more stable base. Right, so that means it's a weaker base. What which means it's easier to form, right? It has a stronger conjugate acid. And so you can get tied up thinking about, all right, so the strong acid has the weaker conjugate base, or thinking of it the other way around, right? The weaker conjugate base would give you the stronger acid, and it's sometimes easy to get those things mixed up. But I would say you're comparing acids, think about and draw the conjugate bases, and then look at ways where that one base may be more stable than the other, right? And there's a couple of factors, basically our size, electronegativity, resonance, and inductive effects, right? And so if you have charge atoms, we can compare all these things, and then the more stable one is easier to form, right? Which means that that acid is going to have an easier time giving up that proton, right? So we need to lose that proton to get there. The more stable the thing you make, the easier it is for that reaction to happen, right? So it takes a little practice. You got to think about it a bunch of times before it gets straight. But for all alcohols, resonance is one of those factors that can affect how acidic the alcohol is.